This is the first episode of All the Ideas by Mad Fellows. Myself, Dan Servo, and Douglas Bebb here. It's something I've been wanting to put together for a while, doing a little podcast, kind of explore our, kind of a knowledge thing, actually. It's really just share our knowledge, what we've done in business and things like that. And I know the podcast kind of wants to have ideas of bringing authors on and stuff like that, kind of interviewing them because I'm a published author myself or coming up here soon with Pro Arduino.
Yeah, we've met so many interesting people over the years and especially recently as we've built up Mad Fellows that, I want to sit down and I want to pick their brains. These people are experts.
Yeah.
In whatever field they're in, if it's 3D printing or engineering or a mathematician.
Yeah.
Yeah, something like that. They're going to have something that, I think that we can learn from them as, individuals and hopefully as a company too.
And if we're going to be learning from them, why, hold that in, kind of do, a little knowledge sharing.
Yeah, so we're hoping really to bring in, a few interesting people, talk to them, get some other book authors, ask them about their books, what they're working on, and showcase some projects that we've been working on over the time.
Yeah, that's kind of what the Mad Fellows Tech blog's about more is, tutorials and things like that. We'll have the podcast there, but we're going to be doing a lot of hands-on tutorials. We'll probably pick a project from a book or two here, and when we do a review on it, we'll actually do a project out of that book.
Yeah, so I'm pretty excited with some of the things that we're going to be able to cover on all the ideas, and I think we've got a great lineup of people that we can talk to over the time.
So why are we calling it All the Ideas?
Well, we are calling it All of the Ideas because we tend to glom things together. We tend to combine a lot of things. Whether it be methodologies, materials, technologies that were never conceived of working together. And I think that kind of goes towards the, innovation lying on the boundaries of a discipline.
Yeah. Kind of like the, other day when we're, helping our friend out with his thing and started bringing some ballet techniques into it.
Yeah. So I guess just to open up that topic, what are some of the techniques and skills that are unique to you that make you a unique builder and a do-it-yourselfer?
I mean, aside from some of the, pretty simple ones, being able to do the fabrication in a lot of different materials, clay, metal, woods. That's a big one. And then always wanting to expand more, learn new things is kind of really what I like doing. Is always going out and finding a new bit of knowledge I didn't know about before, something I can go and play with and try and fail with.
Yeah, I think that's definitely an important one. If you're going to go into anything, especially anything new, you got to be well acquainted with failure.
Yeah.
So if you're not failing, you're not pushing yourself hard enough, and So I think, so what kind of tools do you use in Mad Fellows?
Well, it's, all the, Arduino stuff. I mean, that's a very big one, and, being able to do the electronics there. We've been trying to build up a lot of our tool set that we don't have. So a lot of things are like hand done, being able to file wood by hand, cut something out of aluminum with a jeweler's saw, and being able to just connect it together with a lot of things that we don't exactly have and be able to do with what we have stuff that would take greater amounts of machinery. I know when I was working as a bench jeweler, I built a watch case out of silver by hand, and I had a watchsmith say, "You got this closer in tolerance and tighter fitting than I could have done with the tools I have to be able to do it."
Well, and I think that certainly goes towards a little bit of skill and a little bit of patience will get you a long way.
Yeah.
I think I bring personally a few hammers into the toolbox.
Yeah. Mostly hammers.
But I think it is that diversity of skills that go into it, not just the tools themselves, but understanding different disciplines, understanding different professions, different fields, I think the discussion of woodworking came up earlier, that there's going to be different techniques, different joining methods for different types of woodwork. Say from cabinetry making to a boat making.
Yeah, people with different fields, or with similar interests, you program, I program, but we have two varying methodologies behind how we program. We do have some, common practices that do happen between us, but that's just kind of, what we have to do. But it's the thought process that goes into that kind of artwork. You prefer to use this brush stroke compared to this brush stroke I use. We're still using, cobalt paint or something.
That's one I haven't heard in a while, actually. But
something radioactive.
Yeah. Oh, I thought you meant like the program cobalt.
Oh no. I was talking about the blue cobalt paint, like as in like Michelangelo and Leonardo stuff. Cobalt.
Okay.
Nice blue color.
Okay. Yeah. Well, and obviously I'm not much of a painter or a art historian, so I'm not well versed in that realm. But I will say that one of the methods that I think is a really good contrast of how you can get yourself locked into the tools that you have really easily is when you have a 3D printer. I think, they're great. They're a phenomenal tool.
3D printers are phenomenal.
And they have some things that they're going to do better than just about any other tool, whether it be machining or casting or cutting.
Yeah, they have their advantages and disadvantages when it comes to their production.
Yeah. They've got their niche, but one of my favorite methods that we've used is like when you made a pour spout out of clay.
Oh yeah, the liquor management system that I did a prototype with. I mean, that was really interesting. I mean, it was a lot of curves. I mean, it was something that would have been kind of difficult to do up in a SolidWorks, CATIA.
Yeah, I think that would have been really difficult to get the curves right. And, you were working on it and you're getting the clay softer, you're moving it, this part doesn't work, so you get to pinch a piece off.
Yeah.
And when you're done, you've got something that fits right in your hand.
Yeah.
Because you've been working it with your hands.
Yeah, so all the changes I would have made in the program and had to go and have it fabricated and bring it back, during that whole time, I was able to hold it in my hands, tactile.
Well, and then you also had the advantage, and I think it's great. This really is my favorite low tech method that you've used to prototype something. Is that
proof of concept?
Oh, yeah, correct. Is that you took the time to, you had your colors, so. You made the buttons on it. You made as if there was this window here where the blue thing is. You used straws to represent where the
liquor
plumbing
lines.
would be coming into it. You took junk screws and pushed them in there, so it had actual screws where you would want to join the pieces together if it was molded plastic.
I mean, I got to say the closest field that kind of comes to that is like prop making and stuff. Would be something you would do that, but not a lot of people don't think in the artistic realm when it comes to design.
Something that translates really well to something in metal or a plexiglass or a plastic is another one that, we don't always have a ton of money to put into a project.
Yeah.
We have to be a little bit frugal, especially if it's not a customer-driven project. We're still going to be frugal with the customers too. But
that scrap bin over there, that's full of stuff that we keep digging out.
Yeah, certainly, definitely. I mean, making great use of the scrap is pretty cool. But
remember, it's reuse, reduce, recycle.
Yeah, and I don't know. We're reducing it as we're reusing it, I guess. So
it makes great storage bins. I mean, you have a bunch of circuit boards, motherboards, and there's a ton of useful components on them. But you don't want to sit there and, take the hot air reflow station and pull all the components off of them. It's like,
I need a surface mount resistor. I'm going to go looking until I find one that matches what I need.
You need a Zener diode. You don't want to go down to Radio Shack, find the nearest, VCR. power supply.
Yeah, so but back to what I was saying before is that, something that does translate well to the metal, the sheet metal work is going to be foam board.
Yeah.
And I think, it's kind of exciting to see what can be made out of a little bit of foam board and some Gorilla Glue or tape. And
Yeah, as long as you're not doming or dishing, you're pretty good. But I mean, you can use the foam board if you're going to make some real complex thing, and then clay over it. Use it as a base structure.
So that's combining a couple of cheap, low tech methodologies.
Yeah.
You're going to get something that, at times doing a 3D printer that can take a long time to print. You might actually be able to make a proof of concept faster.
Yeah.
With one of those methods.
Well, I mean, even going with just the proof of concept on the prototype, proof of concept realm, where you start off with something in foam board and then move to a 3D printer, you're still going to have to do a couple of different prints, a couple of different redesigns. We have a current project that we're working on that has been 3 designs in after its initial concept, after its initial foam board proof of concept, and moving to the prototype stage.
Yeah, well, actually, remember the first proof of concept was, based off of a child's toy.
Yes.
So actually getting out there with a Sharpie and
using the Sharpie as a whiteboard.
Yeah.
Yeah.
And writing on this thing and scrubbing it down with alcohol and making sure that everything worked for, just using the shape of the toy, but I didn't have to go out and even make anything for that. I was just able to, find this toy in my kid's room and, I'm going to borrow this, for science.
You sound so evil sometimes, but then again, you come in with like these eureka moments like, I got it. No, you have a kid's toy. That's a Lego, Doug.
Put the Lego down. There's a lot to be said about that.
Yes.
There's, a lot of flexibility if you're getting the right toys for your kids, I guess. So if they're exploring, well, then you still can when you're an adult.
I mean, it's like even using modern video games that, kind of along the Lego concept. You all know what I'm talking about. And being able to do a actual circuit diagram. Well, logic with the, ands, ors, nots, arithmetic logic units, and be able to produce like communication protocols.
Yeah, that's, the fundamental elements that we've built up from.
Yeah.
Really, it wasn't long ago we lived in a world without Arduino.
Yeah.
So
5 years.
And now it's so ingrained in everything.
Was it 5 or was it 2007 or 2000? Nah, they came out a while ago.
It feels like it's always been here.
Yeah.
But in all reality, I know that before they came out with their open source project, it was really working with microcontrollers was to the realm of, engineers.
Yeah. I mean, hobbyists had like the basic stamps, a little bit of the PIC chips.
But it certainly wasn't anything like what we've got today.
Yeah, engineers was the 8051, programming it in assembly and, manually doing your UART timings.
We've got all the way from grade school children and kindergarten age kids that are able to do some beginning electronics, all the way up to, putting these microcontrollers into space or in CERN.
Yeah. I mean, that is one of the, nice things about that tool set as far as Madfellows goes is by, a lot of things, you're saying, 3D printers start looking like a hammer for every project when there's multiple ways of doing it. If you have a milling machine, you're going to look at every project like, okay, how am I going to build this? I'm going to throw it in the milling machine first.
Yeah, and I think, sometimes we can get a little trapped in even the Arduino, that sometimes the Arduino is just the automatic solution, but I think with like the Raspberry Pi, the BeagleBone, that we've started to have some more options. But even then, there's nothing wrong with going to the 7400 series logic chips.
Yeah.
Knowing how to build, does a circuit, has it always benefited best by being even a digital circuit?
Yeah.
You could do a lot with an analog circuit. I have
your
a friend of mine that I've worked with. Yeah, I was building a function generator that was built off of an analog circuitry 555 timer, um, and using that as a driving circuit for an oscillating motor. But no, I have a friend of mine who's an old school Navy electrical engineer, and they didn't have all of the tools that we have today. I mean, so he brings a really different perspective when he's looking at the electronics, when he's looking at a problem, really, and he's going to come up with a different solution to it than somebody that only has the experience of the Arduino. I think the best case scenario is the more skills you have, whether it be for fabricating or producing a physical object or making a circuit, for being able to do it with logic chips all the way through microcontrollers or microprocessors, and building that kind of technology, to different methodologies of coding, that you code all the way down to assembly.
I do pre-assembly. I do VHDL. So
yeah. So you can do down to a very low level of code, and then there's people out there that are programming on Ruby on Rails, and C# and a very high level abstraction.
Yeah, where
of
not
code.
that control.
And that the true best answers may not be one over another. Programming something entirely in assembly is, depending on what that is, if it's real little, that's manageable with one person. But you can certainly do a lot more work quickly, using like an object-oriented C.
Yeah, something, that's kind of why I personally sit through and only do, up to like C++, C, assembly. That kind of covers a whole gamut that you normally wouldn't have, say, with Visual Basic or any of those, kind of tool sets. Is that's a foundation tool. It's a foundation tool that's able to make more tools, and you can keep redoing things with it. Constantly jumping from language to language to language is okay. I mean, I know there's people out there that do it, but you never really get all the way down into the nitty gritty of certain things. I mean, I can easily pick up C# and had to a few times, Ada, and all those programs, it's still all logic flow, but there's just little nuances. It's like trying to learn a different dialect.
Yeah, it's, I suppose in some ways you could call it going from like division to long division. It's just, different what you're going to do with it,
Yep.
Extending things out a little further, kind of. And, myself, one of the things I've dealt with is I've worked on the website that we have.
Mm-hmm.
And for our blog, we're using a WordPress template and all the plugins that go with it. And, for my coding style, it doesn't suit my coding style looking at it, but it looks good.
Yeah.
So, I'm
hope.
pretty satisfied with that. Well, I think it looks good.
So,
But it's not necessarily the way that I would do it, but somebody else, sat down, went ahead, made this to look just the way they want it out there, and then put it up there.
yeah.
And, so now we can take it, we can work with it, change it a little bit. But the madfellows.com page, I actually programmed that just in a text editor.
Oh, that's old school, man. And it's gonna get us in trouble on the internet.
Yeah, it's capable of running on really any browser. You can run it on a text browser. It's able to be viewed by disabled individuals, so blind individuals could still make use of our website with a page reader. A lot of thought is going into that, and then also, making it work on mobile platforms, making it small. But at the same time, I could do all those same things with a code generator, working in an IDE for generating that kind of, I want to visually design my page, and then it'll spit my code out. But personally, I'm uncomfortable with working with those. I prefer to rely on the skills of, I know the HTML, I know how to create a style sheet, and there's no fancy scripting on that page.
Well, I mean that our Madfellows page, madfellows.com, doesn't have to be that fancy. It's kind of our about us. The
Yeah.
Madfellows tech has to be a little bit fancier because we have a lot of dynamic content that we're planning on putting up.
But I think for the amount of content that is up there, that's going to be hard pressed for anybody to find another page that's going to load as efficiently, be as tiny,
Yeah,
be readily crawlable by web browsers and
but
or by
there's
the
a lot of school of thought out there saying that the whole resources are infinite now. You don't need you load a page that has text on it, and that's all you're looking for is the text, and you have 5 bajillion ads, and it's in Flash, and it loads, just takes forever to load. That's
well, and
not
that's
a
even if
concern.
it's not broken. Because half the time I go to a page that's full of that, it seems like it's broken.
Yeah,
Um,
or break something.
yeah, I'll have Shockwave will die in my browser, and then all of a sudden I have 7 tabs that are no longer functioning,
Yeah,
and that's kind of unpleasant to deal with if you tab as much as I do. So
yeah.
but going into that, we've really got, it comes back to this concept of the tools. Not everybody's going to have the tool to want to sit down, or even the desire to sit down and just ping out a web page in a notepad basically, or a text editor. I actually used Gedit on Linux, but
Yeah, well,
same difference.
that's
Um,
that's a discussion for another day.
yeah. I suppose it would be even better if I used like Emacs or something.
Oh, you mean the operating system?
But no, but because I can bring that in there, I do have the ability to sit down and look at a page that's made with all of the fancy bells and whistles and say, this really isn't very optimized. It looks good, but it's not optimized.
Yeah.
If the end result you care about is this, then you're fine.
I mean, just because you have a 4 gig processor doesn't mean your operating system or your Solitaire or a little piddly notepad program doesn't need to take up the entire amount of that 4 gigs.
Yeah, and I think that's something that probably a few programmers could take heed, that not everybody has the same amount of resources as modern day computers.
Yeah, we don't have all Google Fiber.
Yeah. I try to use my cell phone. I'm, lucky to get 3G speeds in the community we're in, right?
Yeah.
So if I'm browsing a web page on my phone, I want it to fit on my screen, but I also would like it to load sometime today.
Yeah.
But so not necessarily, to say that one way is better than another. Certainly you can come up with a good product with these tools. It comes down to the same thing with manufacturing something.
Yeah. Kind of like spend a little more time on the front end before you get into the back end. Don't jump into a project. Sit down with something that's cheap and easy to fail with, and then work, farther and farther in. Start off smaller. We start off on a lot of things with, say, the Arduino. Then we move up to the Mega. Then we move up to the Due. Then we move up to the BeagleBone, the Raspberry Pi. And then, if we need to go from there, it's, the Altera FPGAs, and then, we're looking at a computer at that point.
Yeah. Yeah. So I think, and again, if your end result is going to be X, then, and you've only got one really feasible way of achieving X, then that's the way to do it. But if you've got a choice of methodologies, I just think something that I've seen you do or I do is to start off with the simplest and the quickest. How bad would it be if you spent, a day or two 3D modeling something, and then you've taken, however big it is, to the time it takes to, 3D print it, and then you realize there's some flaw in your design. You've wasted time, you've wasted filament, and you still don't have what you need. You've got to go back and redesign.
Like that one project where it was going to be $200 from Shapeways and looked bad on a fused filament and was slumping, and there's no feasible way to print it without a lot of...
Yeah, it looked beautiful
Yeah.
in a 3D modeling program, and I really got to give it that. It was a very sexy little object, but it just wouldn't. It wasn't cheap. it didn't look good on a filament printer,
Yeah, and I had to,
and it was fragile.
yeah, I had to throw that. That was 24 hours worth of work. That was 3 work days worth putting that one together, and I threw it completely out, and I changed a little bit of the methodology. I went to a different process for some of the components of it, and I didn't think about the way I was building it. I changed the way it was built,
Yeah,
and that lowered the 3D, the print cost for now brackets essentially down to $40, and then another like $5 to get some stuff laser cut.
yeah, and I think that's another great one is using the cutting method. You've got options.
Yeah,
And if you're locked into and definitely initially let's 3D print this entire object because then we can get it done all in one shot and not have to worry about it. But we burned up a lot of time and resources doing that. And in the
that's
end,
learning though.
And in the end, well, we combined a lot more ideas, a lot more methodologies, and now we've actually got a better object because of that. So we're combining the 3D printing, we're combining laser cutting, we're combining that with the electronics, and it yielded a better result by having that. But if we only had looking from one end perspective, I don't think we would have been able to come up with that.
And I gotta say, the biggest thing is getting experiences, just getting experiences and things. Sitting down with a 3D program, sitting down with, going down to Home Depot and buying a piece of aluminum and a saw and trying to cut it, experimenting, finding cheap things to try to fail with. Don't expect perfect all the time. They say practice makes perfect, and I've had teachers tell me that, it's not just the practice part, it's the practicing to be perfect practice.
Yeah, you have to practice perfectly to achieve.
Yeah, you have to practice the perfectness, and the only way you're going to do that is by failing.
Well, and if you're certainly going to bring in other methodologies that are cheaper, like the clays, the foam boards, you're not going to get perfection.
No.
It doesn't make sense to measure everything, to within a couple thousandths of an inch and, to use fine joining methods. That's not the point. It's that you're going to build something so that you can catch your failures before they become disastrous.
Yep. So, well, this is, definitely we're going to be continuing on these kind of discussions with the Mad Fellows Tech blog. So, we'll expand certain topics we've talked about tonight and things like that. So, this is...
And we'll have opportunity to bring in some new things. We're going to talk about different electronics issues and more fabricating, and then, again, some more interviews.
Developments, interviews, all that fun stuff.
Hopefully we can get a few experts to join us.
Yeah.
Because I know I would love to pick some brains out there.
I'm not an expert with getting that one book out?
No. A little bit.
Fine, be that way. Pro Arduino.
You could be an expert. You could be an expert on Arduino, but that's just one perspective.
No, I'm not an expert on Arduino.
But
I'd love to be, but there's people out there that just do it so much better than I do.
No, well, and to have the humbleness to learn from them a little bit, But I think we want to include some people who are experts in things that we're not. So, and I'm looking forward to that.
Yep. Cool. Well, join us next week. This has been All the Ideas here on MadFellowsTech.com. If you have any ideas that you'd like to hear us ramble about, email them to alltheideas@madfellowstech.com.